One of the theoretically most compelling arguments for NR and NMN over niacin is tissue selectivity, the idea that different precursors preferentially raise ND+ in different tissue compartments. If NR concentrates in skeletal muscle while niacin concentrates in the liver, and if you specifically need muscle NAD+ for athletic recovery, then NR might be the rational choice despite its cost premium. This argument appears regularly in supplement discussions and deserves careful evaluation precisely because it's scientifically plausible and scientifically undervalidated at the same time. The animal data on tissue-selective NAD+ distribution is real but limited in its applicability. Rodent studies have shown some evidence of differential tissue distribution for various precursors under specific experimental conditions. The problem is that rodent metabolism, dosing, and tissue architecture differ substantially from humans, and the extrapolation to practical human supplementation has not been validated by controlled human trials with tissue-level NAD+ measurement. Measuring tissue NAD+ in humans is genuinely difficult. Muscle biopsies are invasive. Cerebrospinal fluid sampling is essentially impractical outside clinical research settings. The data that would definitively answer the tissue selectivity question is largely unavailable. What we do have reasonable confidence about is niacin's well-established hepatic metabolism and cardiovascular effects. Niacin works in the liver and vascular system with documented human evidence. For brain NAD+ and neuroprotection, nicotinamide, a niacin derivative, has demonstrated blood-brain barrier penetration and clinical trial evidence. For skeletal muscle, some rodent data points toward NR, but human evidence is weak. These distinctions, while tentative, suggest a more nuanced framework than NMN for everything. The extraordinary claims principle applies here with particular force. Tissue selectivity is mechanistically plausible. Different compounds have different transporter affinities and metabolism rates that could theoretically produce differential organ distribution. But plausibility is not evidence. Extraordinary claims about precision tissue targeting in humans require extraordinary evidence. Specifically, human studies measuring tissue NAD+ levels directly after supplementation. Until that evidence exists, tissue selectivity arguments should be treated as hypotheses to be tested, not established facts to act on with purchasing decisions. The supplement industry regularly sells hypotheses as facts. Tissue selectivity is a hypothesis. Be cautious about paying a tissue selectivity premium for a claim that hasn't been validated in your species.